Okay, so let's start solving systems. Looking at this, a system is going to be when you have two or more equations. For our purposes, we're going to mainly deal with two equations. In this particular case, we want to actually solve using substitution. Not sure why it says elimination there. Nobody noticed it for 2 days now. Anyway, we're going to actually use substitution. To use substitution, what you're looking for is when you have a variable all by itself. So since we have y by itself, we can take what y equals and plug it in. Just like in a scenario when you've had x equal to 2 and everywhere there was an x you plugged in a 2, this is the same thing. So I'm going to take my equation 5x plus 2, and instead of putting y, I'm going to put parentheses, equals 44. But instead of putting that y right there, I'm going to put what y equals. So I'm going to substitute in 3x for y. If you substituted correctly, what you're going to notice is this new equation has only one variable. Everything I have is x's. So then looking at this, we're going to go ahead and start to solve. I get 5x, well 2 times 3 is going to be 6x, and it equals 44. 11x is going to equal 44, and then I'm going to divide both sides by 11, giving me x equals 4. Okay? At this point, a lot of people think they're done. They're not. You're only halfway there. This would graph two lines, and two lines are going to intersect at a point. A point is made up of both an x and a y value. So we've got the x. Now we've got to go to step 3. We've got to plug it back into one of those equations. It doesn't matter which equation. I'm going to pick the easier equation, y equals 3. I'm going to put parentheses because that's where the x should go, but I'm going to plug in what x is equal to. Since x is equal to 4, I would then get 3 times 4 is 12. So now I have x is equal to 4 and y is equal to 12. This is going to be the point where our two lines would intersect. We can check this to make sure it is correct. To check it, we're going to go back and we're going to plug it into the equation, not this one, but the other one. So we're going to plug it into 5 parentheses plus 2 parentheses equals 44. Ran out of space there. I'm going to plug in my 4 for x and my 12 for y. 5 times 4 is 20. 2 times 12 is 24, and it's supposed to equal 44. 20 plus 24 equals 44. So 412 actually is the correct point of intersection. And by checking it, you don't ever have to get this answer wrong. So let's see about trying another. We've got 1/2 x plus y equals 1, and then we got x equals 2y plus 14. This is set up for substitution because your x is all by itself. Since x equals all this stuff, we can actually substitute all that stuff in for x. So I'm going to write 1/2 parentheses plus y equals 1. I'm going to put my 2y plus 14 in for x. Notice the only variable I have left is y. So I'm going to go ahead and simplify this and solve for y. I'm going to start off by distributing. 1/2 times 2y will give you y. 1/2 times 14 is 7. And then over here I got this plus y and a 1. I got 2y's plus 7 equals 1. If I subtract 7 from both sides, I'll end up with 2y equals -6. And then divide both sides by 2 gives me -3. Now I'm going to take that y and I'm going to plug it back into one of those equations. I'm going to pick the one that I think would be easier. So I'm going to say x equals 2 times y plus 14. Instead of putting in y, I'll put in what y equals, which is -3. I have -6 plus 14, so x is going to equal 8. Therefore, we have a point of x is 8, y is -3. Always be careful to pay attention to the order that you plug those in. Now I want to check this. To check this, I need to go use the other equation, the 1/2 x plus y. So I got 1/2 x plus y equals 1. Well, my x value is 8 and my y value is -3. Half of 8 is 4 minus 3 equals 1. 1 equals 1. Okay, this is a true statement, which means 8, -3 is the point where our two lines would intersect. Okay, so now let's look at this one. We'll try another. This one is set up for substitution because now y is by itself. Since y equals all this stuff, I can take that and I can plug it in for y. That gives me 8x minus 2 times all that stuff equals negative 2. I'm going to plug in what y equals in my parentheses. So I've got 4x plus 7. That'll be 8x minus 8x minus 14 equals negative 2. You'll notice 8x minus 8x is 0x. So my x's actually disappear, and I'm left with negative 14 equals negative 2. Since this is a false statement, plus I lost my variable, what it's telling you is that your two lines are never going to equal each other. Negative 14 is never going to equal 2. And if you have two lines that never equal each other, you've got parallel lines. They're never going to intersect. So you have a situation where you have no solution. We got one more to try together. If x equals all this stuff, then we're going to plug it in for x. So I got 2 parentheses plus 6y equals 14. Since x equals all that, I'll plug that in for x. And then I'm just going to start simplifying again. So I got 2 times negative 3y, which is negative 6y. I got 2 times 7, which is positive 14, plus 6y equals 14. If I combine my y's, I end up with no y's. My negative 6y plus 6y is 0y, leaving me with 14 equals 14. This is a lot like the last statement, except this time we have a true statement. I lost my variable. So this is the scenario, not where we won't have any answers, but instead we're going to have infinitely many. In other words, these two lines are on top of each other. They're called coinciding lines. It is the exact same line, and therefore they will have every single solution is a solution. So down here we got a box that kind of sums all that up for you. You've got two intersecting lines. They intersect at a point. They will have different slopes, and you can expect to find one solution. If you have two parallel lines, what will happen is you will lose your variable, and you'll end up with a scenario that is a false statement. This means you've got the same slope, but they're going to have different y-intercepts, and there will be no solutions because parallel lines never cross. Then you have coinciding lines, which means you lost your variable, but now you have 4 equals 4. In this particular case, you've got the same slope, and you've got the same intercept, and you will have infinitely many solutions. So let's bounce forward to our hot pursuit. We have a police officer, and he is chasing a speeder. A motorist has run a red light and is speeding going 82 miles per hour. Okay? We need to, one, write the equations for this, but to do this, you really want to understand what your variables are. So first we're going to identify time. Well, time is going to be represented by hours because it's talking about miles per hour. So we've got time in hours. Then we've got distance. Well, d is going to be your distance in miles. But you'll notice that you've got a little note here that says at t equals 0, the police officer passes through the intersection. So this is going to be distance in miles from the intersection. It's not like it's from each other, it's from the intersection. So to write these equations, they've given us a heads up. It's going to be d equals in both cases. I'm going to let the first one be the police officer, and then we'll let the other one be the motorist. Okay? So the police officer at the time of 0 is actually in the intersection, which means he's no distance from the intersection, but he is traveling at a rate of 90 miles per hour. So he would be a great example of direct variation because at time 0, he's at the origin. The motorist, on the other hand, he's already 2 miles down the road. So he would have a y-intercept 2. He would be shifted up 2 from the police officer. But he's going at a slower pace, which is good. That means the police officer is going to be able to catch him. He's actually going 82 miles per hour. So if we write both of those equations down here, our purpose is we now want to substitute with them. This is one of the easier substitutions, but for whatever reason, students tend to struggle with it. They both have d equals, so you get a little lost in what to do. Do the same thing. Well, if d equals, then I'm going to substitute it in for d. So I got 82t plus 2 equals 90t. So, in other words, if they both equal d, you just need to set them equal to each other. So now I got 82t plus 2 equals 90t. If I started to solve this, I would subtract 82 from both sides, giving me 2 equals 8t. Then I would divide both sides by 8, giving me t equals 1/4. 1/4 of an hour. Hopefully you're thinking that through your head. 1/4 of an hour is actually going to be in 15 minutes. So this was a 15-minute chase. Now that I have my t value, remember, we still have to plug it back in so we can find out how far they traveled. So I'm going to plug it into the one I think would be easier, which would be d equals 90 times 1/4. And if I plug this in my calculator, I'm going to get 22.5. So 22.5 miles down the road. Our ordered pair would be 1/4 and 22.5. And then to check our solution, we would substitute it back into the other one. So let's see, that means d equals 22.5, 82 times 1/4 plus 2. Well, 82, a fourth of 82 is 20.5 plus 2. 20.5 plus 2 is 22.5, so yes, we have the correct solution. Then we have to actually explain the meaning of our solution. So let's see, and remember, we're going to explain in real world words. So I got in 15 minutes, the police officer catches the motorist 22.5 miles down the road. Or you could say from the intersection, okay? I'm going to put just a dot, dot, dot. Actually, it's from the intersection. To complete the table, notice I've already labeled the y for you. I haven't labeled the x. We need to title it first. It says blank versus blank. It's always going to be y. Y versus x. Y depends on x. Y varies directly with x. Y is always going to come first. So in this case, our y value was actually the distance. And then our x value was going to be the time. And you could also have put miles and hours. That would be fine. So then I'm going to go ahead and label my graph. Okay, so we have to label our x-axis. I would just, because it's really small numbers, I would do a fourth, and here you got a half, you got 3/4, and then you got an hour. I know that my police officer, who I'm going to let be blue, well, at 0 time, he was at the intersection. I know after 1 hour, since he's going 90 miles per hour, he will have traveled 90 miles. And now I could go ahead and graph my line. This is the part where you really want to be careful because, well, if you don't, you're not going to get your intersection correct. Okay, then I'm going to let my bad guy, my motorist, my speeder, he's going to be red. My motorist started 2 miles ahead. Now, here's where it gets real bad. We're estimating, and anytime you're estimating with a graph, it's not going to necessarily be accurate. So this might not pass exactly at the point we're expecting it to. Let's see, he started there. He went 82 miles per hour. So in an hour, he'd be 82 miles further, which would put him at 84 miles. And then let's see, I'm going to go ahead and graph his line. And let's see how we do. I know where I want it to cross. I want it to cross at that 1/4, right? And I'm pretty close. I'm just going to make me a big dot to kind of cover the fact that, you know, it didn't quite work out to be that. But I already know because of what we did that at a quarter of an hour, he is going to be 22.5 miles from the intersection. And yes, it's going to be the same. Okay? I hope this helps. Otherwise, I'll see you in tutoring.